This is chapter 3-5, using properties of parallel lines. Please copy your codes. All right, we're going to learn about theorems about parallel and perpendicular lines. This should be rather easy and quick. Okay, this particular theorem doesn't have a name, it just has Theorem 3.1, but you need to know the definition of the Theorem 3.11. Excuse me, not 3.1, but 3.11. And it says if two parallel lines are parallel to the same line, then they are parallel to each other. What does that mean simply? For example, if line P is parallel to Q, and then if Q is parallel to R, then that means that P has to be parallel to R as well. Here it is. If P is parallel to Q, these two are parallel, and then Q is going to be parallel to R, then that must mean that P must be parallel to R. It's kind of like the symmetric rule. Okay? The symmetric property of equality, remember, if the first is equivalent to the second, and the second is equivalent to the third, that means the first and third must be equivalent to one another. Okay? So we have the symmetric, it's kind of like the symmetric property. So if the first and second are parallel, P and Q are parallel, and then the second and third, Q is parallel to R, that means that the first and third must be parallel. P must be parallel to R. Right? And then we have our next theorem, 3.12. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Okay? So that means simply, if line M is perpendicular to P, so if line M is perpendicular to P, and we know that line N is also perpendicular to P, that means they're both going to form 90-degree angles. They're measuring the same angles, which means they have to be going the same exact direction at the same angle. That must mean that M is parallel to N. So these two are parallel if M is perpendicular to P and line N is perpendicular to line P. That means automatically that M and N, lines M and N, are parallel to one another. Again, this theorem 3.12 does not have a name, but you need to know the definition in a plane. We're talking about a plane. So if I have a sheet of paper on a plane here, and if I have two lines drawn there on the surface here, and I know that M and N are going to be perpendicular to P, that means that M and N will be parallel to one another. And finally, proof that's in your book. We're using our books here for geometry. If it says here that we have lines M and N, and it's about a canoe, so please make sure you read that whole first example for the proof. If lines M, N, and K represent three oars on a canoe, then you have line M being parallel to N. M and N are parallel, and then you know that N is parallel to K. You have to prove that M and K are parallel. It's kind of like symmetric property. So here's our given. Remember, we go through our thought process for proving, okay, that writing a proof. And if we're doing a two-column proof here, we think number one, what am I given? And we're given that these two are parallel to one another. Okay, we have a diagram drawn and what's given. Okay, we also know that N is parallel to K. So we've done step one. We've thought about what is given. Diagram is drawn. Step two, what am I asked to prove? That M is parallel to K. These two are parallel is what I need to prove. And finally, step three, I start thinking about, what do I know about this information? Well, if I'm looking here at these, if I know these are parallel lines, okay, M, N, and K are parallel, that means that angles 1, 2, and 3 are all going to be congruent. They are corresponding to one another, okay? Corresponding angles is what I'm thinking. So this might be what I choose to use. This is one option. Corresponding angles are congruent. Just a thought. So we get ready to start with our two-column proof, our statements and reason. I have line M is parallel to N. That was given. Remember, given is generally first. Angle 1 is congruent to angle 2 by corresponding angles postulate. I know that N is parallel to K because that's given at the top. And I also know that angles 2 and 3 are going to be congruent because of the corresponding angles are congruent. That means that angles 1, because angle 1 is congruent to 2, and then I now just show that 2 is congruent to 3 by corresponding angles. That means if 1 and 2 are congruent and 2 and 3 are congruent, that automatically means that 1 and 3 are going to be congruent. And what am I thinking? That's the transitive property. The transitive property of congruence. And then finally, that's true, that 1 and 3 are congruent by the transitive property. That means that M is parallel to K by corresponding angles.